Starting the stream. The stream has started.
Hello, everyone. Wow. I should have thought of a better intro in 5 seconds. Okay, so we are Astronomy Club, and we are currently sounds more like a podcast.
That's kind of what I was gonna say. Like, if what happens is that, especially since midterms are coming, if people end up mostly watching the video online afterwards, it
exactly
becomes a podcast.
That's fine. We can make it into a podcast.
Yeah, fair enough. Yeah. So welcome to the AAUWI fake podcast. I'm your president, Daniel, and with me is my vice president, Kirk.
Hello.
Other two exec members. I'm sorry, I don't really remember positions like that. My treasurer, Michaela, and
We treasure her.
treasury. What?
We treasure her.
We do. So today we're gonna talk about the inner planets. So
The solar system and the inner planets of the solar system.
yeah, pretty much. So basically, this all kind of starts with the sun. So how the inner planets seem to have started, guys, is that there was this big kind of star or the sun. Oh, new person. Oh, it's Arain. Hey, Arain.
Hey, what's up?
So before the solar system seemed to have formed, how stars form in general is that there has to be like a lot of dust and gas in around the same place, and there has to be enough mass for like pressure to form. So I'm trying to think of like an analogy. So imagine. Nope, can't think of one. Because the hard part about thinking about how stars form is that there really isn't anything else like it in the universe. You just need so much mass and dust and gas kind of compressing onto each other to form this kind of body. If there isn't enough mass, you get like a brown dwarf, which is like a wannabe star that didn't work out, you know.
Think a star.
I'm sorry, I didn't want to attack anybody.
Star movie.
Yeah. So so Michaela, I was looking at how stars form essentially, and it just takes like this immense amount of like heat and pressure,
Indeed.
kind of like Portmore.
Okay,
And that's how and that's kind of how stars form. But like when stars do form, they don't always stay the same. So some of them get brighter and hotter, and when the stars get brighter and hotter and bigger, what happens is that the gravity compresses onto the core so that atoms start fusing in the core. The reason why this is like important is because the fusion in the core keeps the star alive. If you can think of like fuel for an engine, the fusion in the core is the engine for a star.
Mm-hmm.
And that is it is so incredibly difficult to force two atoms together much less to make them into like a completely different element. So the hydrogen, electrons hate each other with a passion, and they also like to be a social distance away from the nucleus. But when the star is kind of like Donald Trump, like, yo, ignore all of
Oh my gosh.
just ignore all of that, just pack yourselves into the same room. But it doesn't happen all at once. Usually what happens is that the stars kind of get like, the atoms get like squeezed, and eventually they just buckle under the pressure. It's almost like peer pressure, but for atoms.
So when you have that one really like good girl that she never go out and party or anything else.
Wow.
She start going to a new school, and then all of the peer pressure causes her to become a completely different thing, aka an Andrews girl.
Oh my god.
Oh my god.
I cannot believe that was said. Yes, basically, kind of, really, but sort of. is essentially how that happens. It's that it just takes this high level of pressure that we can't really recreate even on Earth. It takes more energy to split an atom apart than it takes to fuse atoms together. You'll get more energy when you do fuse atoms together, but that's just because the nucleus has this high level of energy that you just really can't force that. It just, even in labs, when they manage to do it, it's for like a fraction of a second, and they can't do it after a really long while.
Mm-hmm.
Just because the energy cost is just like so much. So all that stuff happens on a really large scale. You have a star, right? And when the pressure gets big enough, those elements that fused and combine form more elements. They fuse and combine to form even more elements. So hydrogen is going to get smashed together with other hydrogen and form helium. And then helium is going to smash together to form, I believe, something else, and then forms carbon, and then forms oxygen.
Yeah.
Like that, yeah. So, like, you'll get like lithium in the core, you'll get some beryllium in the core. And fun fact, because like, you know how the universe is like mostly hydrogen and helium?
Mm-hmm.
That's just because it's like, that's the easiest thing to form. When atoms form, they usually form in terms of hydrogen in the universe. But on Earth, we have like tons of not hydrogen, or not just hydrogen. We have rocks that are made of lots of different other minerals. We have carbon, we have heavy elements. Some elements we've managed to like make in a lab, but like most of those don't form naturally. And if they do, they're so unstable that
Yeah.
So kind of how that happens, Kirk, is that stars make that. So any element that isn't hydrogen, stars are really responsible for making that. All the elements that we have pretty much available to us were made inside stars. So there's a thing.
So let's have a round of applause for stars.
Oh yeah, round.
They're like the real stars of the solar system.
Oh, not the brown dwarfs, not the brown dwarfs, but the actual stars, because brown have enough. brown dwarfs don't have enough material to do that, so they look at stars being like, I wish I could be you, but they can't.
Tragic. I feel that.
Yeah, mood, honestly. But yeah, it's kind of interesting to know that like most of the or all of the elements that we have today are pretty much a product of stars. Like gold, all the minerals, all the gems that we have, pretty much single-handedly because of stars. Even the materials that make up us, our bodies.
Mhm.
So, let's see, the oxygen that is part of water, the carbon that is part of literally every life form ever that we all of those are star stuff. The thing is though that if you can like remember the periodic table, you'll get there's hydrogen, helium, like lithium, all the way to iron.
Yeah.
And you get to iron. Iron is like stubborn, so you can't make iron do things it doesn't want to do
That is very true.
without some huge added pressure. But because iron is so stable, iron is like, yo, it doesn't matter what kind of pressure you're gonna put on me right now, I won't do it. So even most stars can't use iron into anything.
Iron is like the weed head of elements.
Oh my god. How did you even come up with that? Where is that coming from?
Yo, you ever tried to convince a weed head to do something they don't want to do? It's impossible.
I just feel like there are so many other analogies you could have made, and you made that one.
Yeah, but like weed heads though, they're a special breed of human being.
I mean, I guess you have a point somewhere.
Yeah.
But yeah, so iron is like way too stable, essentially, in stars. So in stars, usually there are like two forces at work. So there's the gravity that's pushing everything together, and the energy you get from fusion that's pushing everything apart.
Mm-hmm.
When things fuse into iron, when things fuse stably into iron is so stable that it doesn't produce any energy from fusion.
Oh,
So-
cool beans.
Wait, what?
I said cool beans.
Yeah. So, it's almost like tug of war. It's
Mhm.
tug of war, and like there's this big heavy guy that's responsible for like most of the force in the team, and he just lets go, and he's like, nah,
No.
No.
this out.
Mm-hmm.
And they can't. So those guys get yanked over to the other side. That's pretty much what happens with the war between fusion and gravity. So iron is like, nah, you guys produce the energy, I will not. And gravity is like, alright, bro. And pushes. Oh, hey, Cal.
Hey, Kyle.
So,
Good morning, Kyle.
Calm down. Okay.
God.
No need for that.
So, yeah, so Cal, we're talking about the inner planets, like how stars form, because knowing how stars form is like kind of important to knowing how the solar system becomes a thing. So, long story short, stars are kind of like pressure cookers, where they have two forces at work. There's gravity keeping everything together, and fusion pushing everything apart. The gravity is so intense that the atoms get smashed together or squeezed together, and they form new elements. So every element that isn't hydrogen in the universe that we know of is pretty much because of stars and extreme systems like them. And so the elements will get heavier and heavier. New person. What is up? Hellgast Gunner. Wow. What a name.
What a guy.
Wow, amazing. Yeah. So
Fabulous. And then there's the whole, copper-based blood thing. That's how.
Oh yeah, yeah, that too. They don't have the same type of blood that we have. Yeah, so I mean, I think they have purple blood.
Blue.
Hello.
They have
Okay.
Blue. That makes sense. This.
You guys hearing me?
Yes.
Yes.
Yeah, we're hearing you now.
Now, okay. Great. Jesus, I've been
Oh,
talking
you were
to myself for
speaking
so long.
before?
So.
You're
Oh
speaking
my
clear.
gosh.
Yikes.
Yes, all this time.
Wow.
I really hate Dell. Dell can go. Wow. Anyway, continuing.
I mean, we could
No,
hate
my
Dell, we
computers
could
are
hate
Dell.
Flo. It's up to
Kyle?
you, really.
Yeah.
No, floor work if you want.
Basically, in some way,
Mhm.
they use enzymes to just pluck out different RNA bases.
My
So they're
God.
I can't really hate Dell because Dell
Code.
makes really good computers
It does though.
and good monitors. I am actually using a Dell monitor right now.
About money computers. We're not talking about money computers. We're talking
Wait.
about my
Wait.
computer.
Michaela,
Yes.
Michaela, breaking
Yes.
news. So like I kind of knew this a little bit, but I didn't consolidate it until now.
Mhm.
That while we have like red blood and octopi, pods, pussy, I don't know.
Octopi, I think.
Yeah, how like crustaceans and octopuses and squids and stuff have blue blood.
Mm-hmm.
Some like worms and leeches have green blood. Some beetles have yellow blood. Some types of like sea worms, like brachiopods, they have purple blood. So that's a thing. Thanks.
Who went around killing stuff to find all this out?
Don't question it.
Like just, I wonder what kind of blood that thing has.
We're human
yeah,
beings.
Jennings?
We seem to kill for sport. So
Jennings, were you done with what you were saying?
yeah. So it seems to be like kind of like you said, like clearly it's due to like the different kinds of like chemicals and that kind of stuff. For us it's mainly iron. For the ones with yellow blood, it's like another chemical. Yeah, for the ones with yellow blood, it's another chemical that turns into vanadium, which turns yellow.
It turns into what?
It's this chemical called vanabin, which turns into the chemical element vanadium, and when you expose that to oxygen, it turns yellow.
That sounds like either a death metal band or an anime.
Nice. Octopi have copper in their blood, and copper turns this like deep blue.
They also have 3 hearts and a circular brain.
Yeah, copper turns.
Oh yeah, they have
Yeah.
3 hearts, and also 10% of their brain is actually their brain.
Guys,
So what the other 10% is?
That was right.
you
Other
can
90. Jesus
you
Christ,
can-
you can't do maths.
you can click
The
you
other
can
90. The other 90.
you can click the join link in the chat that I sent, and you'll be able to hear the music that's playing in the background.
Oh
Oh.
my god. How many
The
I can't do math?
join link?
This is crazy.
The join link, where is that?
It's in the presentation room.
Oh, okay.
So, Jennings,
Guys, question.
Yes, ma'am.
to add to what you were saying about the insect blood thing, insect blood is primarily for like carrying nutrients and hormones.
Pretty much.
So the color of their blood has a lot to do with what they eat. Because insects don't use blood to carry oxygen because they're just small enough to.
Oh yeah,
diffuse.
to like diffuse stuff.
So they don't need hemoglobin or anything.
Facts. Yeah. Essentially, yeah. So, wow, yeah, good point. Oh, right. So, we're the only planet with all this weird stuff. Where we can have. organisms with like 5 different types of blood, and that's fine. But there's also, I guess, we covered this before, notions that you could get life on other planets, like the other rocky planets.
Mhm.
Rocky planets are the ones that we think are more likely to have life than the gas giants.
Mhm.
What kind
Why?
of life do you
Understandable.
think could spawn in gas giants?
For the person who said why, because soil is important for things such as plants,
Stability.
what we understand to be plants.
Mhm.
Soil is important for them. Soil is kind of important for if we want to go to a new planet and like live there. Soil is important for things like agriculture, what we would eat. That kind of stuff is like important.
I think a large contributing factor is that we only have the only basis we have for what life is and how life functions is what we have right now.
Facts.
Yeah.
Exactly. So, I mean, essentially what we're doing is we're being like, well, we're used to this, so
This has to be how life is.
everyone else must be used to this too.
But at the same time, if we could find some other form of life that operates different, it wouldn't be very helpful to us in regards to wanting to go to a different planet.
Oh yeah, for sure. Essentially, we just kind of have that weakness that we are our own measuring stick,
Yeah.
and we just have to figure it out from there.
Which is why we need to look at octopuses, because they're clearly something else.
Oh my god. oh yeah. One other thing about the terrestrial planets, and it's kind of why I talked about the solar system. All of the terrestrial planets have a core mostly made of like iron and nickel and silicon and oxygen. And those are the elements that are either lighter than or equal to iron in terms of mass.
Mm.
And that's kind of just because of how stars work. Mostly once you get to iron, then it doesn't really fuse far beyond that, and that's why iron is like really prevalent in terrestrial planets. But you also got other rocky things like silicon, you got nickel. Usually those like kind of settled into the core.
Wait, so question. The stars that not stars, the planets that are like fully half made out of diamonds or like gold. What happened there?
Diamond and gold?
Yeah. Like, could you have planets and like asteroids that are 50% just one chunk? It's like the ultimate gold nugget just floating in space. What happened there?
Why would that have been a thing?
Yeah.
Oh yeah, no, it's the same thing I was telling you though, that like when stars, especially when stars supernova twice, that's where you get like a lot of those really heavy elements. The ones heavier than iron with like gold and platinum and those kinds of stuff. That's what happens when really, really heavy, dense stuff crash together. So when neutron stars crash together, or somebody said like when a neutron star and a black hole have some weird jiggy physics. And
Ooh.
no, not ooh. Or like when two black holes interact.
When two black holes love each other very much.
Something like that. I'm not even sure how that works, but I at least know that two neutron stars collide, then you get those really heavy elements. So gold, platinum, those kinds of stuff. If you find any of those coursing throughout the solar system, it's from something like that.
So,
stars. Yeah.
I have a question. If it is that those are the, obviously this is all a relatively small space, but if it is that those are the really heavy elements and they end up all the way out, they are not as abundant down here in the closer planets, is it that those would have been shot out still at a fast speed, but they slow down there? And I don't think I'm Englishing it right.
Wait, what are you trying to say?
Hold on. It's alright. It's okay. When I reword it, talking about you.
Alright. Yeah. So, for heavy stuff, don't really have what it takes. You know how like brown dwarfs don't have what it takes to be stars, because they're not big enough. They ain't grown. So, in the same way, stars don't really have what it takes to make like super heavy elements because they ain't grown. There are levels to this thing. You know what I mean?
There's always a bigger fish.
Exactly. So let's see. Another thing about terrestrial planets is that none of them in the solar system seem to have like ring systems. Like Saturn has rings.
Yeah, why is that? That's whack.
Uranus, Neptune have rings. Jupiter has too, but like they're super small. And they usually the gravity usually takes over and just swallows them.
I petitioned to blow up the moon to make rings.
Are you trying to despicable me this?
If that
I feel like
happened,
that's a bad idea.
if that
Blowing
happened,
up the moon?
Yeah.
Do you want to ever enjoy the beach ever again?
I haven't been in years. I'm not gonna miss it.
I see. Disagree because
No, you see, what I would be doing is I would be bringing the beach closer to everyone who it's kind of far from.
No, sir.
And they want to visit. Haven't been able to visit the beach in years. We're gonna.
I mean, that's instantly like 1 billion people off the coast.
I did.
Yeah, that's it. That's
Just think about
Portmore gone.
Hey, think about it. We've been trying to get rid of Portmore for a while.
Wow.
Alright, so
As soon as you build the theater,
could we not get rid of Portmore? Thank you very much.
I also agree.
All the Portmore people.
I also agree. Thank you.
No, but like, see, okay, think about it. Straying away from planets slightly.
I'm worried you're not thinking about it, Kirk.
Nice.
I've
Like
been thinking about
the moon
it.
helps us stay on our axis. I feel like that's madly important.
But
Oh yeah, that too. If we come off the axis that we're on,
Mhm. But think about it though.
No.
So when
that
you're
alone sets the tone for 2021. Like,
Of course. When you're really rich, you get a private island.
God.
If we blow up the moon, when you're really, really rich, you can get a private asteroid. Just you, your house, your little side chick. You can have your side chick stay on like your moon, your tiny personal moon, and like visit Earth when you have to visit your.
have your side chick stay on the moon with no atmosphere.
Oh,